Hi, everyone. Thank you for joining us today for our presentation on Ethernet switch technologies for the plant floor presented by Joe Amorese. If you have any questions during the presentation today, make sure you submit them using the Q&A function in your Zoom window, and we will be sure to address those at the end. And with that, I will hand it over to Joe for him to start his presentation. Thanks.
Thanks, Chris. Good morning, everybody. My name is Joe Amorese with Horizon Solutions. I'm an automation specialist that specializes in PLC products, visualization, advanced software, and network products. Today's webinar is on Ethernet technologies on the plant floor, and I'm going to go over some things. So the agenda is going to be, I'm going to talk about some definitions. I want to try to get everybody on the baseline. Since this is virtual, I have no clue who's out there talking. I want to get everybody, at least when I start spitting out definitions, to understand they're on the same page. And then I'm going to get a little into the switch technologies, and then just a quick overview of the Stratix switch family of products, and then Q&As at the end. So if everybody's seen this OSI model, the IEEE 802 standard model. So on the upper level, the CIP stack, which I call the payload area. So that could be, it could be our CIP information, which is Ethernet IP. It could be HTTP. It could be voice over IP. It could be pretty much any protocol. So Ethernet IP is unmodified Ethernet. So that means that the lower layers, the physical, the link, the network transport layers, are the same no matter what the payload is. So we're talking about switches today. So we want to be aware that this traffic that we're talking about, it's open. So we got to be aware of that. We're going to focus mostly today, or pretty much all today, on layer 2 and layer 3. And if you heard that, layer 2 is going to be our unmanaged switches, and layer 3 is going to be our managed switches. So layer 2 is based on MAC addresses, which is a physical address, and network is based on IP addresses. So as I said, I want to get some definitions, get everybody on the same page. So back in the day when Ethernet first came out, it was a token passing network, so everybody had a time to pass. From there, it transplanted to a multi-access network. And when it first came out, it was half duplex, 10 megabit. And the thing with that is that only one party could talk at one time. There had to be some arbitration scheme. And the way it worked was they used this thing called carrier sense multiple access with collision detection. So basically what that said is for half duplex, so if a node wanted to talk on the wire, it would listen. If the wire was open, it would start communicating. If at the same time another node decided it was going to talk at the same time as well, they'd have a collision, and both would stop communicating, and they'd go through this arbitration scheme where they'd get some arbitrary random number, and they start timing down again. So both are timing down at different times. So think about this as a large half duplex network with multi-nodes. You could see that with the arbitration being destructive, we're not going to have the ability to have deterministic and repeatable networks for I/O. So after that, full duplex came out, so both parties could communicate simultaneously. When that protocol came out, we no longer needed the carrier sense multiple access collision detection because both parties could talk at the same time. So that's pretty much the modern today with switches. So why am I telling you about half duplex and CSMA, CD? Because the first thing I'm going to talk about is how we can break a network. So the first way we could break our network is this protocol called auto negotiation. So by default, when all of our products, and pretty much all products, come with the configuration of auto negotiation. So the thing is, some people decide that they're going to hard code their nodes or their switches. So say you have a PLC and you say, I really want this node to go through, so I'm going to set this thing 100 meg full duplex. So I set my PLC at 100 meg full duplex. But on my switch end, I leave it for auto negotiate. So what happens when that auto negotiation goes out to that PLC, it says, I can't auto-negotiate that. So what it does is it sets it default to half duplex 10 meg. So now we get into an old style network with collisions. So always use auto-negotiation or always hard set both ends of your nodes. I've seen this many times, and it really breaks the network pretty quickly. So auto-negotiation is by default, and I would leave it there because all of our products come out with negotiation. So if in the middle of the night you need to replace a product and you don't configure it right, you could have trouble with your network. MAC addresses, that's the layer we're talking today. So immediate access control, it's a unique 12-digit number. So the first part is a manufacturer. So manufacturers have a set physical number, and then the last 6 are the hardware address. So we're going to be using that in our examples today. There's a counter called time to live, and so this is important because it defines how our messages are transmitted. So time to live, every time it goes through a router, it decrements by 1. So if we see a unicast message, so that's a point-to-point communication. So our time to live in that is 64. So what's that mean? That means I could route 63 routers. So why would I use something like that? So say you have a building automation system and you have some I/O, say on a different subnet, and you want to control it from a PLC on another subnet. We could do that with unicast messaging. Multicast is one-to-many on a subnet. So multicast is one to a group. And there our time to live is 1. So that can't be routed. So a multicast message always stays within the virtual LAN. And then we have a broadcast, which is one-to-many, or one-to-all, excuse me. So a one-to-all message is like a good example is if you configure AB Ethernet driver and you go do it who, if you notice it automatically populates all the devices on that subnet, that's through a broadcast poll to all the devices who reply. So if you're back in the day, so I've been with Horizon for 25 years, so I came up from the proprietary networks, which in some ways were nice because we had fixed rules, we had a minimal third-party intervention. So we knew the baud rate, we knew the distance, we knew everything. So we pretty much had a deterministic network. It was either going to work or not going to work. When the open networks came out, so the ODVA was the SIP protocol, which had device net, control net, and Ethernet IP. So device level network was for our devices, and that was an arbitration, so it was a carrier sense multiple access, but the bitwise arbitration always allowed the packet with the higher bit to go through, so it wasn't destructive. So it was deterministic. It was repeatable, excuse me, not deterministic because there was collisions. ControlNet was a real-time network. It was scheduled. With that network, you could not build a network that didn't work because it was scheduled and a network update time. So when you went to schedule, if you overexceeded the bandwidth, it wouldn't let you schedule it. So that was our real-time I/O network. And when this first came out, Ethernet IP was 10 meg half duplex. So it was not really considered an I/O network at the time. So times have changed quite a bit. So now we're doing things in sub-millisecond on Ethernet IP due to switching technology and full duplex. So let's talk about some of the old technology again. So a hub was a device that this rebroadcasted all the information across all ports. So again, this is something that you can't buy anymore. If you have one in your facility, if you have one on your machine, please get rid of it. So this is our network of the day we're going to be using for all of our examples. So we have a PLC, node A, node B is a drive. We have a couple switches, HMI, and another drive on D. So the way a hub works is, so say node A wants to talk to node D. So in the I/O tree, you put the drive in there, say 20 milliseconds, and it goes on that drive. So actually, let's say 5 milliseconds. So drive A is talking to drive, or PLC A is talking to drive B at 5 milliseconds. That's the RPI. So what happens? So as a hub, it rebroadcasts to all ports. So not only does D get that information, also B. So why is that a bad thing? Well, let's look at the spec. I don't know if you could see that. So the packet rate, so that the drives are capable of 200 packets per second. So that's after that, they start timing out. So A is talking to D, and RPI is 5 milliseconds. So we can calculate how many packets per second it is with the simple equation is 1 over 2 times the RPI. So at 5 milliseconds, drive D is getting the packet at 100 packets per second. But drive B is also getting 100 packets per second. So say this system had 4 drives on it at 5 milliseconds. You'd see we'd exceed the packets per second of all the systems, because even though B doesn't need that information, B still has to evaluate it and reject it. So D is going to accept it, B is going to reject it, but it still has to evaluate all that bandwidth. So there's in the protocol, we time out after 4 RPIs. So if we have the 5 millisecond RPI, as you see, we start getting timeout. So we could start seeing yellow triangles as the IO drops onto the network. So that's what a hub does to a network. It broadcasts out, the traffic is seen on all devices. So our first polling question, Chris is going to.
Yep, I got it for you, Joe. So first polling question of the day, what type of switches do you generally specify? Give you guys about 30 seconds to answer this. Still got a lot of responses coming in, so we'll give you a few more seconds for the last of everyone to get their responses in. All right, last couple of seconds for anyone to get their responses in, and we will end the polling, and here are our results. I'll let Joe discuss those, what he thinks.
Okay, it looks like pretty good across the board. Looks like quite a bit of the audience is able to, based on application, so they know how to specify a switch. A fully managed switch, I'm guessing a lot of times these are probably the end user type people, and the unmanaged, lightly managed, probably going to be more in the machine builder world. These are just my guesses from what I'm seeing. Thank you. Okay, so let's talk a little about going up the level now to unmanaged switches. So unmanaged switch is designed to simply plug them in, give them power, and they run. There's no configuration involved in all of these switches. So an unmanaged switch is not a dumb device. So it does manage information based on the MAC address. So I said we're working in layer 2 today. So the way an unmanaged switch works is it learns its MAC addresses, and it could send information out the correct port based on its MAC address. So the key to this is for unicast messages. So the rules are the switch learns its source MAC address from the source packets. So in this scenario, again, A is configured to talk to D, and it's got in the IO tree. So it's it's an IO message going to D. So when A goes out to D, the first thing it does, it gets to the switch port 1. So the MAC address table on the switch. So I pre-populated some of these spots. So these MAC addresses I made up. So there's no, to make it easy and clarification, MAC address for this is AAAA, BBB, et cetera, et cetera. So when these switches first come out of the box, this MAC address table is blank, but I sort of pre-filled some things in. So when A wants to get to D, it goes out to port 1. So the first rule is the source address learns its MAC address from the source packet. So when it gets to switch A, it says, I know A is now in port 1. So I fill in my table. Again, our goal is to get to D. So the next thing is multiple addresses can be learned on each port. So you see in port 4 of this, it knows that down the road I have CCC and DDD. But again, if this was like a 16-port switch, I could have this list of 15. So port 1 knows, or switch 1 knows what's on the rest of the network. So let's go out port 4 now, into port 2 of our switch 2. So our port 4 switch 2 is the packet's here, and it says, okay, how do I get to the D from there? Well, my table's not filled in yet for D, so how does it get that information? So what it does, it floods the network. So it actually sends a broadcast out on that network, and it says, where's D? So everything goes out. So for a second there, we're flooding the network with information. So D replies. So now I have a path based on my MAC table to get to D. Notice the drive in port 2 never saw any of that traffic, nor did C. So we definitely keeping the traffic to the ports that it's required to. So versus the hub where we blasted everything. So D got this information. So D's going to reply that it's got its information. So what happens is D populates this table back again. So after a while, these MAC address tables are going to fill up. They do have an age out after 300 seconds, but typically in the networks that we're dealing with, you know, you're working in the 50, 100, 200 millisecond range. So they pretty much stay flooded. So that's how an unmanaged switch manages unicast traffic. Managed switches give you a lot more flexibility, a lot more configuration, and they come in 2 layers, layer 2 and layer 3. Layer 2 uses the MAC address, just like we showed for unmanaged switch, and layer 3 uses IP addressing so you could route across subnets. We're talking about the Stratix family of switches today, which uses the Cisco iOS operating system. So a lot of the features that we're talking about are both Cisco and Stratix. So some definitions. So the first one is IGMP snooping. So that constrains flooding of multicast traffic. So that keeps a switch from becoming a hub. So when you configure things for multicast, IGMP in the switch keeps the switch again from turning into a hub. SIP sync, IEEE 1588, precision time protocol, all the same thing. That's how high precision clock synchronization across the network. And actually, with today's switches and this protocol, we could do a plus or minus 100 nanosecond synchronization. So if you're doing motion sequence of events, timestamp and logging for pharmaceuticals, this is a protocol that you want to have included in your switches. Quality of service prioritizes traffic. So say you have a packet of IO going across, and then you have a packet of motion, which has a higher priority. That motion packet will take priority over other traffic. So motion traffic is one of the highest. Safety traffic is also up there, some of the highest. And things like messages are, you know, they're pretty much on the lower end of it. So VLANs allows the segmentation of networks. We talked about collision domains back in the other day. We talked about multicast traffic. Can't cross VLANs, so a way to manage that. And also broadcast can't cross the VLANs. So it's a way to segregate network and keep traffic to a local area. The SNMP is a management protocol that comes pretty much on everybody's switches, and we're going to use that and see that's in some of the different products we have available. Another thing that's pretty cool is we have this thing called DHCP per port. So what that does is it hard codes an IP address to a port. So why would you want to do that? So say say you have a drive in the middle of the night, the drive dies. You need to replace it. So the maintenance guy or controls engineer goes out and puts a new drive in, wires it up. What this does, it pushes the IP address down to that port because by default, our products come with DHCP enabled. So we actually, without going through and using the bootp server or hard coding in, we could actually push an IP address down to that device. Another thing that drives have, which is pretty cool to complement that, is auto device configuration. So our drives, we can configure those. So not only push the IP address down, we could push the configuration down and the firmware. So just by taking a drive, plugging it in, wiring it in, we could configure that drive and get it up and running without any intervention. So Ether channel is a way to group channels together, so we could actually increase the throughput. So we could plug 2 gigabit ports together and make them an Ether channel, so it becomes one physical port, or one logical port, excuse me, or it could be also a resilient network if you lose one. So it's a way to parallel ports without making a loop. So port mirroring is the ability to mirror traffic from one port to another. So say you have some issues on one of you're talking to that drive and it keeps getting yellow triangles and timing out. So how do you find out what's going on? So you can mirror that traffic to an open port, and then you can use a thing like Wireshark or something. If you could record that information, and then you can analyze it. Either you could, if you know what the traffic looks like, you can analyze it, or you could send it to Rockwell Automation tech support, and they have the skill set to look at that and help you analyze issues with your network. Spanning tree protocols provide resiliency path, but more importantly, they provide loop prevention. So loop prevention, and I've seen this happen, and people's network go down, middle of the night, they plug a cable into the wrong place. So basically, you get a parallel path to the device. What happens is it starts getting these broadcast storm, and the traffic keeps going around in circles, and then no time at all, the whole network goes down. So loop prevention is definitely a good way to keep that from happening. Unmanaged switches don't have that feature, so that's one thing that a managed switch really brings to the table. We have a couple resilient protocols. So resilient protocols, the ring protocol, which is REP. So you still have these convergence times. So this is very important. Remember back, and I was talking about hubs, the 4 RPI timeouts. So if you have a ring protocol and the ring breaks or faults, how long does it take for it to reconverge itself? So our embedded device level ring does it in about 3 milliseconds. So if you're doing high-speed motion, if you got 1 millisecond RPI, you're going to be within that range. The REP protocol is about 50 milliseconds. So if you're more in the slower stuff, so 20, 30 millisecond RPIs, that'll work. The spanning tree protocols are hundreds of seconds. You'll drop everything else. So spanning tree protocols are not a good resilient protocol for I/O networks. Our layer 3 connecting routers, so it's called layer 3, we call it routers, different names, but basically it's ability to connect VLANs together. There's a technology called NAT, which I'm going to show you, embedded in our switches, or it could be a standalone switch itself. And then our smart port. So again, our static switches are our Cisco operating system. So if you're an IT person and you understand the command level interface, basically you program through a command line. So there's a phone book size command line. So you really need to know the language of Cisco. What Rockwell brought to the table is when we partnered with Cisco is these thing called smart ports. So smart ports are macros that run based on the traffic that you're configuring. So when you configure the switch, you click on the port and you say, oh, okay, I want this to be an automation device. Or I want this to be another switch. Or I want this to be a wireless. Or I want this to be a PC. It'll configure all those CLI commands for that port. So it makes a controls engineer the ability to configure these switches without really knowing the whole language of the CLI. So it's a really nice way to do it. Some other things to bring is so we have port control. So programmatically, you could manage your ports. You could look at traffic, broadcast storms. So with that and our add-on profiles, which is so it will become I/O and I/O tree. We can not only manage, we can monitor and visualize what's going on with the switches. Another thing we have is MAC ID port security. So with an unmanaged switch, that switch is open. So anybody could plug into that switch and have access to the network. So with a MAC port security, it looks at the MAC address. You could set an IP address. You could say port 1 is going to my PLC. This is the MAC address. It's the only traffic I'm going to allow on that. So there's a lot more security in an Ethernet managed switch versus an unmanaged switch. So pre-version 18, our traffic was all multicast. That was, so that's where we had, where TTL1 really came into play, and also the ability to manage IGMP. So if you see here, unicast Ethernet IP is pretty much a default on all our products now. It comes checked. The only reason to uncheck that is if you're doing things like if the ability to do consume tags. So if you have a PLC and you want to produce a tag and you want to consume it by more than one controller, that will be a multicast message. If you're doing listen-only I/O connections, so a controller has the ability to own an Ethernet or a I/O module, but another PLC would have the ability to listen to that. So you get real-time information from inputs and outputs. So with that, it's also a multicast. Our older Kinetics 300 through 50 and PowerFlex Series A drives were multicast only, as well as the Kinetics 6800. And there's still some third-party products out there that are multicast. So if you're putting third-party products on the wire, just check and make sure that they support unicast, or make sure you get the switches to manage that traffic. So what does multicast do for us? As I said, multicast is the ability to talk to a group. So my group happens to be just one at this time, but so basically it says I'm going from A, I want to talk to B. Notice none of the other nodes in this saw the traffic because multicast was turned on with multicast was managed with IGMP, which is a managed switch function. Here's IGMP without multicast. Basically, remember that old hub? Well, we just turned that switch into a hub. So now everything on that network is seeing all the traffic. And again, so this might have timeout issues. So manage your multicast with IGMP. I said we have this technology protocol called network address translation. So if, say you have a plant full of machines and they're all, you have 10 machines that are all identical, and you want to keep them all identical, so you use the same IP address scheme for all of those machines. We have the ability to translate those IP addresses up to a different network. So we could say 192.168.2 is going to be 10.10.11.3 on this network, and this one over here, which is the same IP address, is going to be 10.10.10.3. So I can get that information from an upper level network. So we translate from one to the other. So this is, if you're a machine builder, you build at 192.168, and then you bring it to the end user facility. They have the ability to, instead of changing all the IP addresses, they could just NAT it. So again, that's a function in some of our switches. It's also a standalone appliance. So with that, I'm going to talk a little bit about just a product overview of what we have. So in the Stratus family, we go from our unmanaged rail switches, our Stratus 2000. So we have a lightly managed product, the 2500. Our 5700 is pretty much our lead product in the machine world. The Stratus 8000 was our original offering. It was a modular switch, but that has an end of life of coming up at the end of this year. So if you're thinking about purchasing one of those, give us a call, please. The Stratus 5400 is our gigabit family, and then the 5800 switch, which is a new product that's not available yet, but it's soon to be released. And then we have our distribution switch 54 family, which is the DIN rail switch. So our unmanaged family, we go from 4-port to 16-port. Again, these are very cost-effective switches. Again, unmanaged, plug them in and play. They come with either copper, you can get them with fiber, SFP for single or multi-mode. So there's a few flavors available for this. Our lightly managed switch, it's been out a couple years now. So this is a switch that you could just, like an unmanaged switch, you could just power it up and populate it with nodes. And by default, IGMP is turned on, so you could ability to manage your multicast. So some of the things it also has, though, it has the DHCP purport, so you could push IP addresses down. We have some cable diagnostics information. This is a CIP SIP protocol, so we have Studio 5000 add-on profiles for configuration, so we can actually bring that in as I/O and monitor the traffic. So this is a plug-and-play managed switch. It comes in 5 and 8 port at this time. Our 5700 is pretty much our bread and butter line. This is a standalone switch. It's not modular. You buy it either by the port count. You can get 6, 10, or 18. We call them 20 port. So this is our layer 2 switch. It has all the feature set of the switch. Be careful when you spec these out though. So when they say, so like this one right here is a 10 port, but it's showing 12 holes. So these two are groups. So we have an SFP, small form factor pluggable, which could be a fiber or could be another copper, and we have a copper. So this is one port. It's either or. So if you see things grouped together, when it says grouping, be careful not to count that as 2 ports. So some of the features of the highlight available on the 5700 comes in a light firmware and a foam firmware. So there's a price difference between the two. So depending on what protocols you need or what you need available will determine what firmware you need. So the IEEE 1588 is a separate option only in full. So that is probably one of the times you definitely need full. But as you can see, we could help you spec out the availability and the difference when you go to design a system. So they both support DLR as well. So this is our new modular. So this is going to replace the 8000, 8300. It's going to be both layer 2, layer 3, depending on which one you purchase. But it is modular, so you could buy the base and then add on different modules to the right. So we have a full variety of power over Ethernet, fiber options, and copper. So again, this is going to be sometime in the late fall. I don't have a firm date yet on this, but this is definitely going to be the product that's taken over the 8000 series. Our 5400s are gigabit family. So this is again layer 2, layer 3 switch. It has it's sold by a number of ports as well. And then a technology called embedded switch. So our products, pretty much all our products today, our controllers or I/O modules, come with dual ports. So those dual ports on the switch are actually a switch. So embedded in that switch is the quality of, it has quality of service, it has IGMP, it has SIP sync, all embedded in the switch. So that using that in topology, we could do a linear topology without a switch. We could do a device level ring, so a fault tolerant network. See, if you notice, we have switches that sit on device level ring, so you could branch off and go to other devices like HMIs. The topology I really like, especially for machine builders, is this hybrid topology, I call it, where we got our high speed, time sensitive products all daisy chained together. So we could have, so like this is controller, this is our new, say, 5069 compact logic. We could have 32 axis of motion with a course update of 1 millisecond. And then we could have some other devices. So this is all really SIP sync or our IEEE 1588 sensitive information that we put on the wire. And then we can go to a switch at the end, and then we can go to things like our HMI, our drives, other ancillary devices. So this topology, this hybrid topology, is very robust, very robust. So I really like that topology. And lastly, we have a product that's been out for a couple years now called FactoryTalk Network Manager. So Network Manager is a product that you could download. If you go to the AD website, you could download the product. There's no charge for the ability to just go look and browse your network and see what's going on. So it auto discovers the SIP protocol, the SNMP protocol. We also could do BACnet, Modbus, Profinet, NetBIOS devices. It'll go to automatically auto browse and build your network to generate this topology. What's really cool though is the ability to manage your static switches with it. So there is a cost for that. So it's $35 a year per switch for that feature set. But we could do backup of our static switches. We could do ability to auto recover. So you could do auto configuration, and you could do troubleshooting. So this is a great product for managing your networks. Okay, so some of the key takeaways. Again, always use auto negotiation. That's a good way to break your network if they're not matched. Manage your multicast traffic. That could do the same thing. So unmanaged switches are okay in the right applications. If you notice, the unmanaged switch is not dumb. So in the right applications, if you're not doing things that are really time sensitive, or everything's on the same switch, unmanaged switches are okay. And again, if you have questions, please give us a ring. We could definitely help you lay out a network. Never use hubs. Again, you can't buy them, but you never know. You might find one on the shelf, dust it off, and put it on, and you know what happens when we do that now. DHCP per port is a great way to make your life easy for managing replacement of products. And manage loops. With that, have Chris have another polling question?
Yep, we do. So to sort of wrap things up, what would you like to see as a follow-up webinar to this presentation? Give you guys a little bit of time to answer this again. Still have answers streaming in pretty consistently, so we'll give you another few seconds to get the last of your responses in. All right, another couple seconds to those last few responses. All right, and here are our responses. So Joe, looks like you got potential next topic for another webinar, and definitely some general interest all around.
Okay, excellent. Well, thank you. So let me work on coming up with a standard troubleshooting tools for Ethernet IP. And if you know that, if you use the IAB tool, there is a network design feature in there, and it shows you bandwidth, shows you packets per second. So the ability to look as you're building a network to see, how much traffic you have on the wire. So, and then we also have embedded web technology in all of our products, as well as in RS links. So, okay, I'll take that to heart and see if I can come up with a good troubleshooting for Ethernet IP. Thank you. So with that being said, that's the end of my presentation. Again, I'm Joe Amorese, Horizon Solutions. We thank you for participating. And please, if you have questions, fire them off.
Yeah, we do have some questions lined up that I will go through, Joe, and you can answer them. So the first one is, if someone's currently using lightly managed switches, are there any security concerns around those as far as, things to set up or, features they might be missing security-wise?
No, there's the lightly managed switch, I believe, allows MAC address configuration. I need to check into that more, to be honest with you. I'm not positive. Okay,
so we'll make a note on that one, and we can send a follow-up with some answers for that. We had a couple that kind of, I think you ended up addressing, but kind of wrap into the same one. Are there, what would be the best tools for designing and setting up a network?
What kind of monitoring tools? Is that question monitoring tools or design?
So there was one wondering about monitoring tools for networks and also some about designing a new network.
Okay, so designing a new network, the Integrated Architecture Builder, which is a free tool downloadable from the EB website, has the ability to build a network with switches and put all your devices on there. and it'll actually calculate the packets per second and the bandwidth of that product. So it'll tell you the performance of the network. As far as monitoring tools, again, so if it's a lightly managed switch, we have the add-on profile as well as the faceplates. There's a web browser tool available for that, so you could look at it and go through a web interface, HTML and or HTTP, and look and see at the actual switch configuration and statistics. But the add-on profile gives you all the tags, so that information is embedded right in your controller.
Perfect. Let's see, next one. Is there a benefit to using NAT instead of having multiple PLC Ethernet ports on separate subnets?
Well, the advantage of NAT allows you to have the same IP addresses on multiple machines, and then as you NAT them, you could see them all in a central location. So if you have separate switches, if you have the same IP addresses, you can't connect them together. So say you wanted to bring that data up to a higher level data collection. If they were the same IP address, you couldn't plug them in together. You'd have duplicate IP addresses. So it segregates areas of the machine to bring up to a higher level network. So say you're doing historian, or you're doing some kind of data collection, or OEE. You want to get information from all those machines. That would be probably the way to do it would be through NAT. Or our new controllers, our new 5069 family compact logic controllers, they're dual port, but those ports can be set for unique IP addresses, for unique subnets. So with our new high performance controllers, we could set one to like 10.10.11, and we could set the other port to 192.168.1. So that can alleviate the NAT issue as well.
Perfect. Thank you. Another one that came up, if someone's getting noise on their network that's causing communication issues, what sort of devices or tools are out there to help prevent that?
Well, the first thing, we didn't talk about layer one, which is the Ethernet media. I'm a very big proponent of Cat6e shielded 600 volt cable for everything. Buying commercial off the shelf Cat5e unshielded in a machine environment give you troubles. Again, using port mirroring and using Wireshark is one way. There's Panduit has some network analysis tools available to actually put on the wire and see it. So there are some troubleshooting tools available. Fluke has one as well, and so you could plug in those and you could see what's going on with the network.
Perfect. Next one, what sort of applications or devices can take advantage of power over Ethernet?
We typically see that in cameras, things like, especially machine vision cameras. That's where the most prevalent area of PoE we're seeing right now, in video type stuff. But I think as the products evolve, we're going to start seeing more things with PoE. You got to remember, PoE is 48 volts with milliamps. You're running through 18 gauge, 20 gauge, 24 gauge wires. So it's low current draw products. But the most product I see are vision cameras that are doing machine vision, and things like barcode readers and things like that in the machine world.
Perfect. The next one, can you review the timeline of the Stratix 8000 end of life, and when will the Stratix 5800 switches be available?
Well, we have a definite end of life for the 8000, which is 11/30/2020. So like the last day of November, that switch is no longer available. As for the new family 5800, the timeline I saw is fall. So, I mean, as you know, with Rockwell, they don't tell you, they don't give you a exact date. So I'm hoping, and it's been in the works for quite a while, for a late fall release, but I can't give you an exact date.
Okay. Next up, what is the ring heal time compared to an Entron?
So Entron and ring, I think that was in the 50 millisecond range. I'm not positive, but it was within the tolerance of an IO network.
Okay. There's another question. I'm just reading through it. This one has one that I will chat to you quick, Joe, just because it has a abbreviation I'm not quite familiar with. But while I type that one up, Cat6e switches, are there many out there yet? The last project that was worked on 2 years ago, this was an issue. The shield needs to be grounded versus a ground bar on Cat6 switches. So it sounds like, the question is, are there a lot of switches out there yet that support Cat6e?
Yes, all are gigabit switches. So our 5400 family is gigabit. Our new 5800 is going to be gigabit. Our 5410 is gigabit, and actually that one's 10 gig as well. So yes, they're all gigabit switches now.
Okay, perfect. And I just sent you in the chat the first part to this next question, and then follows up with, depending on what group you ask, you get either auto-negotiate or fixed for those two options I just sent you. Any idea why, and is one preferred over another depending on the application?
Again, there's two schools of thought. I think the majority of the camp is for auto-negotiate, because everything comes auto-negotiate, and you don't have to go in and configure the switch for the hard code. Both will work, but with the latter though, you have to be diligent and make sure that you set those to the proper so they match. So auto-negotiate, it's one thing that less you have to worry about when you're configuring a product.
Perfect. And then I think this is the last one. What is the easiest NAT solution to deploy and maintain?
I like the 1783 NAT-R device. It has a web interface. It's go in and plug and play. So we have basically three products. We have the 1783 NAT-R. We have a 9300 NAT, and some of our switches, our 5700, support NAT as well. So pretty much all of them, you assign your local IP to a public IP. So it's just building your table. So they're all very similar. When you start getting to the upper level ones, like our 54 Family 10 supports three NAT rings, where the other ones are one. But other than that, the 1783 has the easiest GUI to do it though.
Perfect. Well, I think that wraps up all of our questions. If anyone else has any last minute questions, we can hang on for another couple minutes for you to submit those, but I think that wraps things up for now, unless Joe has any other closing comments.
Oh, no, I thank you for your time.